Welcome friends. In this session I am Professor Mohammad Tariq, working in the Department of Economics at AMU Aligarh. In the last lecture we had talked about some of the concepts related to this return on an asset. We said that the return on asset could be anything. It's a random number. It could be 0, it could be positive, it could be negative, and the return on the asset could be assigned certain degree of probability. So in order to analyze the return on asset, we must know the characteristics of a random variable. So while discussing the characteristics of the random variable, we had taken a variable, suppose random variable x or random variable y, and tried to calculate the mean value of that random variable as well as the variance of that random variable. X, or it may be either denoted by x or denoted by y, but there is every possibility that there could be a set of random variable. When we go and make investment in portfolio, the investments are being made in a number of assets, and the return on all those assets are random variable. Those assets could be correlated or those assets could not be correlated in terms of their return. So let us first discuss about the characteristics of two random variables simultaneously, and this will be parallel to this, analyzing that the portfolio is being distributed into assets, suppose x and y. So we had talked about this expected value of x, which was equal to x bar. We had talked about this variance of x, which was equal to expected value of x square minus x bar whole square. So similarly, we can talk about this variance of x plus y, which was equal to expected value of x plus y minus x bar minus y bar whole square, which is equal to expected value of x minus x bar plus y minus y bar whole square, or this is equal to this, you can write down as expected value of x. This we take it as a, this we take it as b. So a plus b whole square, if we apply this formula, this will be equal to a square plus 2ab plus b square. So this is equal to expected value of x minus x square plus twice into expected value of x minus x bar into y minus y bar plus expected value of y minus y bar whole square. So this you can write down, this is equal to sigma x square plus twice into this term we call it as the covariance between x and y, and we denote it by sigma xy plus sigma y square. If the two assets are completely uncorrelated, the return on two assets are completely uncorrelated, then in that situation sigma xy is equal to 0. and in this case we say that variance of x plus y, this is equal to sigma x square plus sigma y square if x and y are uncorrelated. They are not correlated, or what you can say, they are independent when x and y are independent. So in that situation we say this, the term let me explain again this term, the covariance between x and y, which we have denoted by expected value of x minus x bar into y minus y bar. If we write down this, like multiply this can be written as xy minus xy bar minus x bar y plus x bar y bar. So if you take the expectations, this is equal to expected value of xy minus y bar expected value of x minus x bar expected value of y. Since expectation of any constant number is the constant itself plus x bar y bar, so this is equal to expected, so this is equal to expected xy minus y bar x bar minus x bar y bar plus x bar y bar. So one gets cancelled out. So finally we are left with expected value of xy minus x bar y bar. This is the covariance between x and y. If the two assets are being denoted by the term 1 and 2, so you can write down x1 and x2, x1 and x2, x1 bar and x2 bar. The covariance between the return of two assets, it could be positive or it could be negative, or there could be no relationship between the return of one asset and the return of another asset. If this covariance is positive, if the covariance between x and y, if there is no relationship, then in this situation what we can say, expected value of x y minus x bar y bar, this is equal to 0, or what you may call it is expected xy is equal to x bar y bar. Then the return on one asset is completely uncorrelated with the return on another asset. We cannot say anything about this. If this covariance between x and y, if this is positive greater than 0, then in this situation the mean value of return on x, the mean value of x, if whatsoever it is, or the return on x, if it is greater than the mean value of x, the return on y will be greater than the mean value of y. Similarly, this is called as positive correlation. This is called as positive covariance. Positive covariance rather. If covariance between x and y, if this is less than 0, then we say that if the mean value of x, any value is greater than the mean value of x, any value of x is greater than mean value of x, then the value of y will be less than the mean value of y. So there is an inverse relationship. This is called as negative covariance. So in this case, the relationship is uncorrelated. Here, if x values are greater than the mean value of x, then the y value will also be greater than the mean value of y. Here, if the x values are greater than, in case of negative covariance, x values are greater than mean value of x, the mean value of y will the value of y will be less than the mean value of y. So this is about this, the covariance. So the return on asset in case of the portfolio where we are making investment, in case of portfolio where we are making investment in more than one assets simultaneously, the total return on asset could be assessed or could be analyzed on the basis of average return on the portfolio, the variability in the portfolio, and the covariability between or among the portfolios. What is this? The mean value. The mean value we denote it by expected value of x. The variability we denote it by variance of x, which is equal to expected value of x square minus x bar square, and the covariance we denote it between x, between two, we denote it by this expected value of x y expected value of x y minus x bar y bar. So with the help of these three statistical tools, we are in a position to judge our portfolio. We will take one example, one hypothetical example we will be taking in this case. And what is that hypothetical example? This hypothetical example we may take, suppose we are considering a random variable like tossing a coin, tossing a die. So if you are tossing one die, this is a case of a random variable x, and if we are tossing the second die, this is the case of random variable y. So yesterday we had calculated, when we toss one die, the expected value when one die is tossed, the probability of occurrence of dots, any dot is equal to 1 by 6. And what will be the values of x? The values of x will be 1, 2, 3, 4, 5 or 6. Here we had calculated expected value of x was equal to 3.5, that we had already calculated yesterday, and the variance of x was equal to 2.92. And for the sake of similarity in unit of measurement in mean value or the variable itself and the variability of the variable, we make comparison not with the variance, rather we make comparison with a standard deviation. Standard deviation. And what is a standard deviation? This is standard deviation. This is equal to the square root of variance of x. This is just for the sake of making unit of measurement similar. So this is was 2.92, which was approximately equal to 1.70 or 1.71. So this was the standard deviation. Now when we toss two coins simultaneously and try to find out the variance between x and y, there we have to calculate the variance of x plus the variance of x plus y simultaneously. So the variance of x plus y, this is equal to expected value of we have already calculated this variance of x plus y, already calculated this, which is equal to sigma x square plus twice sigma xy plus sigma y square. This, the first page, we have already calculated this. So if we go and make a calculation like this, that the calculation on 2 die is similar to making investment. It is similar to making investment in 2 stocks. Similar to making investment in 2 stocks. So when we make investment in 2 stocks and the weight of each and every stock is equal, such that W1 is equal to W2 is equal to 1 by 2, then we define that the two random variables similar to this x plus y. We define this random variable z, which is equal to average of x plus y. The weights are the weighted average of x plus y. We define this z. So here we try to define this by variance of x plus y by 2, which is equal to variance of z. Clear? So first calculate this mean value of z, expected value of z, which is equal to expected value of x plus y upon 2. What was the mean value of x? If you are tossing a die, the mean value is 3.5. Clear? So this is equal to 1 by 2 expected value of x plus expected value of y. What is this? The expected value of y, x, the mean value of die we have already calculated. This is equal to 3.5, and another die which is also the average value will be 3.5. So this will be 1 by 2 into 3.5 plus 3.5. So this will be equal to 3.5. Now just talk about this variance of z. Variance of z is equal to variance of x plus y by 2, which is equal to expected value of x plus y minus x bar minus y bar upon 2 whole square, which we can write down like this, which is equal to 1 by 4 into expected value of x minus x bar into y minus y bar, x minus x bar plus y minus y bar whole square. Now this can be written as this is equal to 1 by 4 into you say expected value of x minus x bar square plus twice into expected value of x minus x bar. This is a plus b whole square on this formula plus expected value of y minus y bar whole square. So what is this? This is variance of x, this is variance of x, this is covariance between x and y. So what is this? If the two assets are uncorrelated, the return on the two assets are not correlated, this term comes out to be 0. So this is equal to 1 by 4, and this variance we have already calculated. This variance is equal to 2.92 in case of a die. So this is 2.92 plus 2.92, this term being 0. So what is this? This comes out to be 1.46. And what is this standard deviation of z? This is square root of 1.46, and this comes out to be 1.20, which is less than this number 1.71. So what do we infer from here? Our simple inference from here is this, that if we are making investment in portfolio, the average return remains the same as in single asset, but the volatility or the risk factor, it has reduced from 1.71 to 1.20. This is the case when investment has been made into portfolio. This we have tried to understand with the help of the example of tossing of two die, where the probability of occurrence of 0.123456 is equal to 1 by 6, and the two die are independent. That is why the covariance term we have taken it as the 0. So this this volatility is what in the investment, or the variability, larger variability in the investment. What does it show? It shows the risk factor. So it shows the risk factor. So risk factor has reduced considerably when the portfolio is divided into two assets. When you divide this into three assets, the risk factor goes down, will go down further. When you divide this into more than 3 or n factor, the risk factor will go down further. So this is the simple concept of this portfolio investment. The portfolio investment tries to reduce the risk factor, or it reduces the risk factor. This we have proved mathematically. Now we come to the basic issue of this return. As the return on an asset, I told you the outcome of the asset is unpredictable. It can be anything. There could be a loss, there could be a gain, there could be no loss or no gain. So it could be anything. It is unpredictable. That is why we say that this is a random variable. So now we basically come to the concept of this random returns. After going through this, the concept of mathematical expectations, now we come for this random concept of random returns. The concept of random returns we can understand with the help of the two spinning wheels that normally we see in the casinos. And these spinning wheels are of two types. One is known as wheel of fortune and another one is known as betting wheel. One is known as wheel of fortune and another one is known as betting wheels. The wheel of fortune is a wheel where when we spin the wheel, the chance of landing at a particular spot shows the amount of return that you will be getting. When the wheel is a spin, what will be the amount of return of bet? Suppose you bet certain amount, rupees 1 on the spin. So what will be your return? That is mentioned on the particular area of the wheel. Normally under the wheel of fortune, suppose this is the wheel of fortune, the area is being equally divided. Suppose these are the area is equally divided. We assume that these are the equal divided area. So equally divided area is there. So each area constitutes of 1/6 part. This is 1/6 part, 1/6 portion. This is also 1/6 portion. This is also 1/6 portion. This is also 1/6 portion of the area is there. So the probability of falling the arrow on particular area is equal. And what is that probability? That probability is equal to 1/6. But the amount of return is different on different segment of the wheel, on different portion of the wheel. What is that amount of return? Let that amount of return is being denoted by, suppose if you spin the wheel and the arrow stops at this point, the amount of return could be rupees 4. Here it could be a loss of -1. Here return to -1. There could be 3. There could be 0. So when you spin the wheel of fortune, where if it stops over here corresponding to this arrow, your rate of return is 4 rupees. If it stops at this point, you will be losing 1 rupee. If it stops, you will be gaining 2 rupees. Here the situation will be that of no profit or no loss. Let the total return be denoted by R. So what about the betting? The betting will be decided again on the basis of the mean value of return and the variability of return. Mean value of return means expected value of total return, and the variability of return means the variance of the return, total return. So what is this mean value of return? Expected value of R. This is equal to expected value of R. This is equal to Pi, Ri, I is equal to 1 to. Here the entire wheel has been divided into 6 segments. So this is equal to 1 to 6. So this will be equal to P1 R1 plus P2 R2 plus P3 R3 plus P4 R4 plus P5 R5 plus P6 R6. Since Pi's are equal, which is equal to Pi, as Pi's are equal, which is equal to 1/6, because each area of the spin we have assumed to be the fixed each area is divided into equal parts, that we have already assumed. So what is expected value of R? This is equal to 1 by 6 into the return factor, which is 4 minus 1 plus 2 minus 1 plus 3 minus 0, and this comes out to be 7 by 6. This comes out to be 7 by 6. Now, what about the variance of R square? We try to calculate this variance of R square. The variance of R square is equal to expected value of R square minus R bar square. So, expected value of R square, this is equal to 1 upon 6 into 4 square, this minus sign, when we take the square, this will become plus 1 square plus 2 square plus 1 square plus 3 square, 0 square minus 7 by 6 square. Yeah. And this entire area, if you calculate 16 plus 1 plus 4 plus 1 plus 9 minus 7 by 6 square, 49 by 36, this entire comes out to be 3.81. This entire comes out to be 3.81. So, what is the average return? The decision will be taken on the basis of this average return 7 by 6 and the variability in the return, which is 3.81. Clear? So, this is this. Now, there is another concept that we had talked about. This is the total return, the rate of return. If we talk about the rate of return, what we had in the last lecture achieved, established this R is equal to 1 plus R. The rate of total return is equal to 1 plus rate of return. So, what is this R? The small r is equal to R minus 1. And what is this? Expected value of R. This is equal to expected value of R minus 1. This is equal to expected value of R. We have already calculated 7 by 6 minus 1. So, this is equal to 1 by 6. This is expected value of R. Now, what about this? Sigma R square or variance of R, which is equal to sigma R square. So, this is equal to expected value of R minus expected value of R whole square. Clear? So, what is this? Expected value of, what is this R? R is equal to R minus 1. So, you write down R minus 1. What is this R? Expected value of R. This we have already calculated. This expected value of R is equal to expected value of R minus 1. This is equal to, so minus expected value of R, this minus and minus will become plus whole square. So, this 1 will get cancelled out. So, this is expected value of R minus R bar, expected value of R bar square. So, what is this? This we have already calculated, this term we have already calculated 3.81. Clear? So, the variability will be the rate of return, it will be 1 by 6, but the variability in the rate of return and the variability in the total return, this will be the same amount. If we try to draw a plot between for rate of return R, if we try to draw a diagram graph for this R, we take this R on this axis and it will be like this. The minimum amount of rate of return, this could be -1, and what is this average? The average amount -1, because in this situation whatsoever you have invested, the entire amount will be lost, and the diagram for this will be like this. This you can and this value will give you the mean value of R. With in this example, what is the mean value of R? Expected value of R was 1/6. So this will be equal to mean value 1/6. So the minimum value cannot go beyond -1, because in case of the -1, whatsoever you have invested, the 100% will be lost. So it cannot be less than this one. So this is how we are in a position to explain the return on the portfolio with the help of Wheel of Fortune, where the investment has been made into different portfolios with return 4, with loss 1, with return 2, with return minus. This is not the definite return, and all these returns are with certain degree of probability. And what is those probability? The probability here is equal to 1/6. So with 1/6 probability, we have tried to explain this, that decision by the investor will be taken on the basis of mean return and the variability in the return, or the rate of return and the variability in the rate of return. And what do we observe? The variability in the total return and the variability in the rate of return is same.